So here the structure, yeah. Why we store the data in this way, yeah. And there is some reason, yeah. So this, because the 2D array, we have rows and columns. We have rows, 2D array. Yeah. The basic structure 2D array. We have certain number of rows, then a column, right? Like this, all right. And suppose this is the data in a table. Then let's understand the PHP 2D array. Yeah. 2D array in PHP. The basic structure. Okay, all right. Yeah. So we know the 2D array. PHP use this array of arrays to store 2D. So what's the meaning? All right. So that is, the meaning is an array of elements. So we can understand with each element which has each element as a 1D array. Yeah, that's the understanding. Yeah. Yeah. All right. Array of elements. Yeah. All right. So in PHP, array is understood as an object. One array is treated as one object. Okay, all right. But this object is a special type of object. Yeah. In this object, we store a sequence of elements. Okay, all right. And each element could be another object, right? Yeah, a sequence of objects. Yeah. A sequence of objects. So what kind of special objects are stored as the elements of this array? A sequence of arrays. A sequence of 1D arrays. Okay? A sequence of 1D arrays. Yeah. Each element is one object. So this object is 1D array object. Like that. Okay? An array of arrays. All right. So that's the basic structure, the PHP. Yeah, many other programming languages also use this way. It's not special. This is not a special way, just the usual way. Now I like to specify, use a simple example to specify the structure. Okay. Array use a pair of brackets to do the representation. Yeah. Then, so here, I write a 2D array example. All right, yeah, let's say 0, 1, 2, 3. Okay, all right, first element. Second element, 1, 2, 3, 4. All right. Then third element, 2, 3, 4, Okay, that should be enough. All right. Yeah. So let me use this example to show you the details of the data stored in a 2D array. So this is a 2D array, right in this way. You can see these 2D array, if we use an array of arrays, then you can see the outer array has 3 elements. Okay? 3 elements. Each element is a 1D array. Okay? Yeah. All right. And each array represents one row in this 2D array structure. Okay? If we use the 2D way to write the data. The first row 1, sorry, yeah, I need to write here. Yeah, row 1, 0, 1, 2, 3, row 1. Row 2, 1, 2, 3, 4. Row 3, 2, 3, 4, 5. Okay, yeah, so the data is stored in this 2D way. All right. All right. Then, so you have. Oh, yeah, I need to write here. Yeah, I just got confused. 3 rows, 4 columns. All right. Then, excess array elements. Next, 2D, using array indices, row indices, column indices. Here, let me just use one variable. Okay, let me use this my. Sorry, I need to write here. My. Let me just. Example, my ARR equals this. Okay, all right. Then I access. I use the ARR. First, row number. Yeah. So let me use R. Sorry. In PHP, we use this dollar, okay? Dollar variable. Dollar R, okay, row number. The first row index. That's the first dimension. We use the row number. Yeah. Second dimension, column. Okay? Yeah. So this expression we need to access. We can access the element at $R row index. Because row index starting from 0. Yeah. If we say no row number, you may use row number from 1, right? 1, 2, 3, 4. Yeah. But a row index from 0. 0, 1, 2, 3. Yeah. At the $R row index and $C column index. Okay, yeah. All right. So for example, here, my ARR, if I use row index 1 and the column index 2, okay? Yeah. If I access in this way, then, because row index 1, that means this row. Column index 2, that means this column, okay? All right. So this 3. Yeah. So you get this number 3. Yeah, that's the basic understanding. Yeah. With this background, now we can understand the data, our data storage here. Yeah. All right. Here, after I compare, because here we retrieve the data. Next, we need to display the data. So these two parts we need to put together to understand. Yeah. So you won't get confused. And the way I do here, different. Yeah. So that's part. Yeah, because something unusual. So that's why I want to explain. Otherwise, you study by you get confused. All right. Why unusual? Right. So here I tell you the way I store the data. Pay attention to the to the array. Row index, column index here. That's the unusual part. Okay? Focus on this row index, column index. Yeah. Row index, column index. All right. Here, I did the opposite way. Yeah. So, what's the meaning of opposite way? All right. Look at this. This is our original table. Oh, sorry. I need to write here. This is our original table. Okay. All right. Table, we have its natural rows and natural columns, right? Yeah. Table, we have natural rows and natural columns. When we store the data, we copy data from table to the array. Yeah. If in the natural way, you should copy the first row as the first row of 2D array. Second row as 2D array. That's the natural way, right? Yeah. But here, due to some reason, I will explain that reason later. Due to some reason, okay, there is some special reason. Yeah. Then I copy the data in this way. Sorry. Yeah. I copy the data in this way. Okay? All right. So that's the table data. Yeah. So here, this is data in the 2D array. All right. Yeah. How special? All right. Then the row becomes column. Columns becomes row. Okay? Yeah. Row 1. Okay? Yeah. Okay. First row. Second row. And so on. Okay? Yeah. Then the column becomes column. Yep. So C1 becomes the, original. All right. The first column, let's say this column, in this PHP to the array, we start in this way. Okay. All right. Yeah. So one row becomes one column becomes one row. Yeah. All right. Yeah. Why do that? You may ask me, why do that? Yeah. All right. The reason to do that is for convenience. Yeah. So when we copy the data, retrieve the data, in this special way, we feel a little convenient. Yeah. All right. So let's look at. So then, let's think about. In this while loop, every time we retrieve one row data, right? The original table, one row. But when we copy, look at, we fix the second index, because second index, that corresponds to row index. First index corresponds to column index, because we did a transpose. Okay? We did a transpose. Row rows become columns, column becomes rows. All right, so here, this corresponds to row index. This becomes column index. Okay? Yeah. When we do the data copy, because in our one iteration, yeah. So our here it is a nested loops. Okay, outer loop, while loop, inner loop for each loop. Yeah. In the outer while loop, each iteration corresponds to one row. Inner for each loop, each iteration corresponds to one element in the columns. Yeah. One of the column elements. Okay, yeah, that's the inner. Yeah. All right. Then, in the first while iteration, we need to copy the data from the first row of original table, right? Original first row. Then the row index should be 0, right? Yeah. So empty, nothing. Start from the lowest available. Yeah, here. A pair of brackets around nothing in PHP. You do not specify the number. Then it uses the lowest available index number. So when you start, lowest available index number, that's 0. Okay, 0. Lowest unoccupied. Yeah, because that position, there is no data occupied. So the first time you use 0 here. Okay, you fix the row index 0, then you copy, because the $I incremental, and each incremental $I value corresponds to one element, one column value, right? One column value. So you copy, you go through, yeah, so here in this for each loop, you go through all the column values, and you copy by changing the first index number. First, that's the column index. That's the column index, okay? All right. So that means you copy the first row. All right. The first row, index 0, the first time you copy in this way, okay? Yeah. So your row index is 0, then you copy all the column values. Second, yeah, because the next available index, incremental, natural, incremental, so becomes 1. Second time you copy. Third time you copy. Okay? All right. Yeah. So in this way, your 2D structure, yeah. So you need to be aware of how did you copy the 2D data. Yeah. Yeah. All right. Because when you retrieve, you need to use the same structure. Okay? So your understanding of the 2D data, when you retrieve, you use, yeah. So what I said before, why are we doing this way? Because this is the unnatural way, right? Yeah, I agree. This is the unnatural way. Natural way, we should not do the transpose, right? Natural way, we should not do the transpose. So this unnatural way, the main reason this unnatural is for convenience. Why for convenience? Yeah. In my next screen, I will show you why. Convenience, okay? Yeah. When we retrieve the data, yeah, so this way, there is some convenient way to get some important numbers. Yeah. So, yeah, I will show you that point. Yeah. It does not mean you cannot do in the natural way. You do not do the transpose. You just, you can do that, but when you do that, some steps you need to do things very carefully. Yeah. Some steps you need to, get the numbers carefully. Yeah. Yeah. You can do it. Yeah, you can do it. Yeah. Here I need to show you the, display part. Yeah. Yeah. All right. So let me save this. Screen before I move to a new screen. Yeah. Yeah. Save. Yeah. Let me. Yeah. Control S. Let me use. Yeah. Because I couldn't find the save button. Yeah, let me use Control S to save. Yeah, all right. So let me put, because here we are in Module 5. Module 5, Part A. Yeah. Let me put some name. Okay. Page 1. Yeah. Yeah. Later I will change to different number. Page 1. Today. Save. Yeah. All right. Then I can move to the second page. Yeah. This time, I want to show you the display part. Yeah. Display part. Yeah. Let me look at the time. Yeah, I should not use too much time. Yeah. Try to control. Yeah. All right. Because this part, all right. Yeah. All right. Yeah. So I'm gonna take a screenshot. Move. Yeah. Move like this. Okay. Oh, sorry. Yeah, here. Key display. Yeah. This should be enough. Yeah. The main part should be enough. Then our second page. All right. New. Oh. All right. Covering this much. Okay. Yeah. All right. So that's page 2. Now, in display part. Yeah. So why I say convenient? All right. Look, we use nested for loop. Outer for loop, inner for loop. Okay. Yeah. Outer for loop used to display data row by row, right? Yeah. So row by row. Oh, sorry. Okay. Well, yeah. Touch. Yeah. Too sensitive. Too sensitive. All right. So display data row by row. All right. Row by row, then we need to figure out the number of rows, right? Yeah. In the outer for loop, how many rows do you have? You need to figure out that. All right. So here, you can understand why I say for convenience. Yeah. How to get a row number. Okay? How to get a row number. Yeah. Here I use this PHP count function. Count function, dollar, data to the ARR, the first element, 0, the first index, that corresponds to the first element, yeah, the first row. Right. First column of our table data, right? Yeah. Yeah. Remember? Yeah. So here, let's go to the, our storage structure. Storage structure. All right. Okay? All right. First index 0, that means the column. Okay? Yeah, because when we store our data, the first index, that's our column index. Okay? Yeah. All right. Column index. Then yeah. So this corresponds to dollar data to the ARR of 0. Okay? Yeah. We start in this way. Okay? All right. Then, how many rows? How many rows? The number of elements in this array. The number of elements in this array. We use count function. Count function, PHP function, returns the number of elements of 1D array. Yeah, 1D array. So that corresponds to the row number. Okay, that's the way we get a row number. Okay, yeah, yeah. All right, yeah. So that's why I said for convenience. Yeah. Otherwise, the other way we can also, yeah. How do you get a row number? Yeah. Yeah. Your first index is row index. Yeah, think about that. All right? Yeah, you have a way. Yeah, yeah. So you may need to, use a special way to retrieve the row number. Yeah. Here, we use this way, retrieve row number. All right? Yeah. All right. Yeah. So then, in this way, but when we after we understand the way we store data in this special way, then you can see, yeah, yeah. Here I cut off, yeah, my data part I cut off, yeah, but then yeah, I want to, yeah, because this part I cut off, yeah, yeah, but here I just use one special place, yeah, this part here, all right. 1 and $J, yeah. $J, that's the row number. Yeah, our second index, that corresponds to the row number. First index corresponds to the column number. So this is the row index $J, column index 1. Yeah, that's the meaning. When we copy data, we also use it this way. Second index for the row number. Yeah. First index for the column number. Fields, $K, fields, that's the column number, right? Yeah. Yeah. Because fields correspond to the column. Yeah. So in that way, all right. Yeah. So this place I cut off, yeah, you will see, yeah. So the cut off part, if I write it out, it should be $K, yeah, because that's the column number. Then second index $J. Yeah. So we copy the, $J column, $J row, $K column. Okay? Yeah. So this is for the row number. This is the column number. Okay? Yeah. So in your understanding, this part, so do not mess up. Yeah. So I spend a lot of time, Otherwise, very hard. Yeah. All right. Then another important thing I want to mention. Yeah. Why here I use 1 and one place I use 0. Okay? Yeah. So here actually I cut off, because this edit function, this one actually I use 0. This 1, all right. So this function, JavaScript function, edit this row function. There are 3 variables. The first one, actually this one, yeah. I should, yeah, this one, the actual number here, it should be 0. Okay, yeah, this should be 0. All right. The first parameter, we use the data column index 0. Second, we use column index 1. The first two parameters. Then the third parameter, the row number, $J, row index number. Okay, passed to. So here, let me explain why I use these three parameters. Edit this row. We want to edit current row. Click edit button. We want to retrieve the data of this row and display it. All right. Here, one technical problem we need to solve. When you edit the current row, you need to retrieve the data of the current row, right? Yeah. Although we display it, but we need to go back to the original database to retrieve. Yeah. We need to go back to retrieve. Okay? All right. But when you go back to your database, how do you identify the current row? You need to, because when you do the query, you need to pass the information that is enough to identify the current row, right? Think about this. How do you identify the current rows? All the current rows, okay? Yeah. In the 5 tables given, only 3 of the 5 tables, they have primary keys. Remaining 2, they do not have primary keys. If you use primary key, you can only identify 3 of the tables. The other 2 tables, no primary key. How do you identify those 2 tables without primary keys, right? Yeah. Here, I find a way. I find a simple way. This is the way I found. I use it. If we use the data from the first 2 columns, column 0, column 1, column index 0, column index 1. First 2, we need to use data from 2 columns, first 2 columns. Then it's enough to identify all 5 tables. Yeah. Okay. First 3 tables, last 2 tables, with primary keys, without primary keys, we can use first 2 columns, the data, yeah, enough to identify all the rows. So that's why I use the first 2 parameters. So I send data of the first 2 columns back. Yeah, when I do queries, I specify these 2 data of these 2 columns. Then I can retrieve the whole row, the data of the whole row. Yeah. All right. The third parameter, row number, row index, because I need to change the display information for this row. Yeah. Otherwise, after I retrieve the row data, how do I update in the user interface? I need to update at the right place, right? Yeah. How do I get the right place? This row index number tells us, we should update. So here, look at this div. This div, I use the ID. I use the row index. Row index. This, after some name. Yeah. Block. So I want to view it. Yeah. Now I want to hide it. Block. View it. Yeah. So, when I retrieve the data, when you need to update, I show this div and hide that div. Okay? Yeah. After I update it, then I show this div and hide this one. Okay? See? Hide one, show the other. Yeah. Using the display value, block or none. Yeah. All right. So one edit function, one update function. Okay? Yeah. All right. Yeah. Try to understand the logic. Yeah. All right. Then we need to go to the edit function. Okay? Yeah. we need to go to the edit function. Yeah. All right. Yeah. Yeah. But today, I only have 30 minutes left. Yeah. Yeah. So let me. Yeah. Today we understand the data structure. Yeah. 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 Because this part is very confusing. Yeah. Next time. Next time I show you the, we edit function. Yeah. We access database. So we do query, retrieve data. Okay. Yeah. Because we need to work on the data between client and server. Yeah. Client and server. Yeah. Here we do at the client side. Yeah. Yeah. Client side. Display data at the client side. Yeah. All right. So next time we will do the communication between client and server. Okay. Yeah. All right. So today I just want to start this topic right here. Yeah, because I need at least 30 minutes to talk about complex query topic. All right, let me bring up the module 5, part A. Okay, all right. All right, yeah. More complex queries and indexing. Yeah. All right. First, 8.1 exists function. Yeah. All right. So when we write complex queries, yeah, many queries we can use this exists function. Very simple. Yeah. Its meaning, the way to use it, very simple. Yeah. But sometimes when we use this way, we can do many complex queries. Yeah. First, let me explain this function. Yeah. Check. Yeah. So you apply this function on a query. Yeah. So on a query. Okay. Check whether the result of a correlated nested query, inner query. Yeah. Yeah. Inner part. Yeah. Yeah. Usually it's a correlated. Okay. Yeah. Outer query correlated, then nested inner part. Yeah. Another query. Yeah. So you check the query result. Sometimes could be empty, right? Yeah. So you apply certain condition, but after you run it, it returns empty. No data returned. Okay. Yeah. Empty. So this function check if the return result is empty or not. So exists. Yeah. Exists, not empty, exists, right? Yeah. If it's not empty, then exists. So true if the nested query result contains at least one tuple. Yeah. There is something, at least one tuple, that exists, returns true. Yeah. Yeah. False if the nested contains no tuples, empty. Yeah. It's false. Yeah. Yeah. So this function is so simple. Yeah. Yeah. But yeah, later you will see many of our complex queries, nested correlated queries, we can use this way. Yeah. Yeah, very convenient. Yeah. Very useful this way. All right. Then there is a negate version. Yeah, because exists, not exists, right? The not exists function. Yeah, because sometimes we are interested in the empty result, right? Yeah. 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 Exists, we are interested in the non-empty result. Yeah. Our focus is at the non-empty part. Yeah. So we need to use exists function. But sometimes our focus is on the empty part, right? Yeah, we want to get the empty part. Yeah. So not exists. Yeah. So true when it is empty, yeah, the inner query is empty, then it's true. So we want to, select those rows that return empty result. Yeah. False, not empty. Yeah, yeah. You know. Yeah. So these two versions. Yeah. Yeah. Pretty simple. Yeah, yeah. But could be very useful. Yeah. Used in conjunction with a correlated nested query. Yeah. All right. Yeah. Because all our complex queries are correlated nested queries. Yeah. So this is one way we can do. Yeah, let me show you one example here. Yeah. Using exists function, compare. Yeah. All right. Yeah. So the first version, we do not use exists function. Yeah. Our old query. Yeah, we did that before. Okay. Yeah. So here, yeah. Join two tables, employee table and a dependent table. Yeah. All right. So then, you know, yeah. So the dependent, with the same sex with the employee. Yeah. So that's a simple one. Yeah. But we can write an exists version. Okay. Yeah. All right. Then, yeah, outer query, employee table. Yeah. Inner query, yeah, exists. All right. Then on the inner query on dependent table, you select. Okay. Then you specify, you know, condition, yeah, with the outer query. Then same name, yeah, same name as the employee name, and the same sex condition. If it exists, you select that employee. See? The logic also pretty natural. Yeah. Also pretty natural. Yeah. So the different way to write. Yeah. So here you can see, yeah, when I did a grading, many students already use this structure, but they didn't use the exists function. They use a different way. Yeah. That way, from the structure, very similar, but that way is different. Yeah. So let me give you the other way. Yeah. The other way, yeah. Several students using that, you know, similar structure. All right. So here, this inner part, you know, in this where part, yeah. So they use this way. In operator, remember in operator. They use the in operator to, you know, do the similar thing. Yeah. So what's the in operator? For example, E dot SSN, right? Yeah. E dot SSN. In inner query. Yeah. There is a inner query. Okay. Yeah. Inner query select. Yeah. Then dependent table SSN, right? From dependent. Okay, all right. Dependent, you know, as D, yeah, all right, yeah, as D. So, and where E dot F name equals D dot dependent name and yeah, the remaining, so E dot 6 equals D dot 6. Okay? Yeah? See? We can do the same thing, right? Yeah? That's in operator. Yeah. So here you compare the similarity. Okay? These two ways, where basically we do the same thing. Yeah? Yeah. you know, yeah. So that's you compare these two ways so you can understand on the what situation you can use the exists function, right? Yeah, because so many students use this way. Yeah, so many students use this way. Yeah, actually, I noticed when we do the table join, many students prefer this way. Quite some students prefer. Yeah, because whenever this is a simple table join situation. Yeah, I noticed several students whenever they see table join situation, they use this in operator. Yeah, okay. Yeah, several. Yeah. It's okay. But there is one problem. One problem I like to point out is when you use this way. In one situation, it's not good. Okay, in one special situation, this way is not as good as that one. Yeah. On the work situation, remember, we have one question. So that Tokyo, remember, so that supplier from Tokyo. That question, we need to join 5 tables. Yeah, that question we need to join 5 tables. Yeah, too many tables to join. And I saw one student using this in operator way to write the query joining 5 tables. Then that student used the inner query nested 5 levels. Yeah, because join the first table, you have 1 nested level. Then you join second table, you have second nested level. Then third. So then you have 5 levels. Okay, yeah. So this structure too complicated. Yeah, because people don't like this complex structure. Okay, yeah. So our basic idea when we write queries, we want to make the structure of our queries as simple as possible. Yeah, because we want better readability. We want the readability better, right? If too complicated, the readability is very bad. Yeah, because some other people need to read your code. When you write, so you need to, make it easier for other people to read your code. Yeah, but if you do the nested query 5 times, then people get lost, right? How to keep track of the data nested query in 5 levels, right? Yeah. This way, you join 5 tables, still easy to read, right? Yeah, because in 1 level, although you have 5 tables, but in 1 level, right? Yeah, so you join 5 tables. Yeah. Yeah. 5 join conditions. Yeah. 4 join conditions. Yeah, 5 tables, you only need 4 join conditions. Yeah. That's not too hard to understand. The structure, very simple. Yeah. Yeah. So here, under that situation, then there is a difference. Okay? Yeah. If join 2 tables, no difference. Yeah, because you only have 1 level nested query. Yeah. So not hard to understand. Yeah. Yeah. So that's the main problem. All right. Yeah. So that's this exists function. Here, this version may not be easier than that version. Yeah, but here we use this as an example to show, how to do the same thing using this function. Yeah, yeah. But if you know this way, sometimes you can do more. Yeah, you can represent. Some special structures in this way. Yeah. All right. Another example, not exists. Retrieve the name of employee who have no dependents. Yeah. No. Yeah. So no dependents, not exist. Yeah. So if you think about no dependent, yeah. When you retrieve the dependent, so you connect. Okay. You connect outer query employee SSN, you connect to the inner query dependent. All the dependents, it returns nothing, empty. empty return. That's what you want, right? Yeah. So in this situation, you can see not exists is better. Yeah. Because you're interested in the empty return, right? Empty result. Yeah. So very convenient. Yeah. 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 Here. Okay. Yeah. All right. Another one. Retrieve the name of. Yeah. This one is very hard to understand. Very confusing. Yeah. This probably the hardest query in this class. Yeah. The hardest. What I mean, the hardest to understand. Yeah. This example. Retrieve the name of each employee who works on all the projects controlled by department number 5. Yeah. First, we need to understand the meaning. Yeah. Understand the meaning. Yeah. All right. Retrieve the name of each employee. Yeah. So let's consider other query one employee. Yeah. All right. That employee need to satisfy this condition. We know each employee works on a certain number of objects, right? Certain number of objects. Okay? Yeah. So this one particular employee, we get a list of objects, projects. Yeah. So project list. Okay. Yeah. Project list. Yeah. Certain number of projects. Okay. All right. And this list work on all the projects controlled by Department 5. We know Department 5 controls certain number of objects, right? Yeah. So Department 5, okay? All the objects. Yeah. So let me write it here. Oh, sorry. No, yeah. Here. All right. Another list. This object list. This is controlled by Department 5. Another list. Yeah. Two lists. Okay, two lists. Yeah. Then, this question, we need to find those employees. This list, employees project list, should be contained in the Department 5 project list, right? Yeah. So this is a subset of that list. Okay? Yeah? Because work on all the projects. Oh, sorry. Works on all the projects. Control. Oh. Is that the other way? Work on all the project controlled by Department 5. Is that the department, this list contained here? Right? Department 5. Because this employee works on all the projects controlled by Department 5. Yeah. So that looks like that is a subset, right? Yeah, because this employee works on all these projects. Yeah. Probably some more. Okay? Yeah. This employee may work on more than those projects, right? But all the projects controlled by Department 5 are worked by this employee. Yeah. Yeah. That meaning. Okay? Yeah? Yeah? So first we need to understand the meaning. Yeah. So then we need to look at how to represent it. Yeah. All right. Yeah. So here we use this except operator. Yeah. Except operator. Yeah. Because many DBMS do not support that. Yeah. So don't worry. So here we, in the logic we use except, because if we really need to work in some specific DBMS, we can get around it. Okay. Yeah. we use in operator, not in operator, we can get around it. Yeah. So we don't worry. Yeah. So we use this operator to write the logic structure of this query. When we need to replace it, we know how to replace it, right? In, not in, to replace it. Yeah. So we do not worry about that part. Okay. All right. Here you can see, yeah, we use not exist function. Okay. Not exist function. Yeah. Very convenient. Here you can see this query very hard to represent. Okay. Very hard to represent. But if we use not exist function, yeah, we can represent it easily. Yeah. How to represent it? All right. Number, P number, project number, list project number from the project table where D num equals 5. That means all the project controlled by department 5, right? Yeah. All the project controlled by department 5. Yeah. So here, let me draw. Yeah, draw here. Okay. The first, this query. Okay. This query. So let me use one circle to represent. Circle A, yeah, set A. So this circle represents all the project controlled by department 5. Okay, by department 5. Then we know these projects all worked by this current employee. Current employee, yeah, based on the statement. Yeah, the current employee should work on all the projects controlled by department 5. Okay, yeah, but the current employee can work on some more, right? Other than these projects, the current employee can still work on a few more other projects not controlled by department 5, right? Yeah, that is allowed. So the second part, second inner query, that's the project list worked by the current employee. It should be another set larger than set A, yeah, set B. Set B should contain set A, right? See? Yeah. Because the current employee, the first part, the current employee should work on all the projects controlled by department 5, but add a few more other projects, right? Yeah. Adding some more projects not controlled by department 5. All right? Think about that. All right. So these two sets have this relationship. Okay? That's a relationship. All right. Then we use set A except set B. Is it nothing? Right? Look. So if we, with this relationship, we use set A except set B. Is it empty set? Empty set, we use this notation. Empty set. Yeah. Empty set. Okay? Yeah? Empty set. See? Yeah. Empty set. Yeah. Because how to represent that? Except, yeah, empty set. Yeah. Empty set, how to detect empty set? How to detect empty set? Not exist function. That's the perfect. So this situation, you can see, it's the perfect way to detect empty set. How about that? Okay? Yeah. So this example, you can see, yeah, why these two functions are very useful. Exist function, not exist function, yeah, in this situation, so useful, right? Yeah? Yeah. Otherwise, think about, for this example, if you do not apply this not exist function, very hard, right? Yeah? Pretty hard to represent. Yeah. So that's the power of this this special function. That's the power. Yeah. Yeah. All right. So I like you. So I said this is the hardest question of this class. Yeah. Hardest in understanding. Yeah. It may not be the longest. Yeah. Just a few lines, not too long. But the understanding part is relatively hard. Yeah. Understand the, relationship between these sets. Yeah. All right. And in our homework assignment number 3, I need to, before the Thanksgiving break, I need to give you our last homework assignment number 3. Okay, query question part. Yeah. So I will give you 15 query questions. Part B. Part A is still a quiz. Okay, Part A, you do a quiz number 5. Okay, quiz number 5. Part A. Part B, you need to work on 15 complex queries. Yeah. Complex, all nested, correlated nested queries. Yeah, that's complex, right? Yeah. And the next class, our Thursday's class, I will give you another important technique. Yeah. Yeah. So I have to talk about that in Thursday's class. Yeah. A very important technique. Yeah. Then you can do all these 15 questions. Yeah. And the question like this structure, yeah, I will give you 1 or 2 questions. Yeah. Similar to this structure. Okay? Yeah, similar to this structure. Yeah. All right. And here, there is another important point in this example using the negation approach. Yeah. So here, you can see why. Yeah, because here, not exists. That's negation way, right? Yeah, not. Okay, negation way. Yeah. But in the original question, you cannot see any negation information, right? In the original statement, okay? Retrieve the name of each employee who works on all the projects controlled by no negation information, right? Yeah. Yeah. But when we do analysis, we need to represent this relationship. And this relationship, yeah, so then the empty set, yeah, because we need to detect empty set, yeah, then we need to use this negation way. Yeah, not exists. Yeah, that's the connection. Yeah. All right. Next. Yeah, I don't have much time. Next, I need to talk about negation approach. Yeah, because we need to, the previous slide, some student need to, write something. Yeah, because I do not have much time left, so it's not enough to start a new topic, right? Yeah, negation topic. Yeah, negation topic. We need to spend quite some time to understand this negation approach. Then next time, first I finish. So Thursday, I need to do 3 things. 3 things Thursday. First, I need to complete the negation approach. Show you some examples. Second, I need to give you, the special technique I mentioned. A powerful special technique. Yeah. It's called a with clause. Okay, with clause. Yeah. So that technique also very powerful. Yeah. So I need that topic I need to complete. And the third one, I need to complete the data communication between client and server, the coding explanation. Yeah. So we need to look at how to send data between client and server. Yeah. So I use the edit feature to show you, how to send the data between client and server. Yeah. So these 3 topics on Thursday. Yeah. Then you before the Thanksgiving break, you have 2 assignments. Quiz number 5, as part A of homework assignment number 3, and then part B, 15 complex query questions, yeah, before the Thanksgiving break. Yeah. But the due date, after Thanksgiving break, I will give you another week, yeah, because this assignment, you need more time, yeah, especially the complex queries. You need more time, okay? So after Thanksgiving break, you have 1 week to complete it, okay? Yeah, but yeah, so you have more than 2 weeks, yeah, more than 2 weeks for our last assignment. Yeah, that's our last assignment. Yeah. Home assignment number 3, last one. Yeah. All right. Yeah. So that's what do we have today? Yeah. Yeah. So let me stop right here.